Let's take a look at quadratic factors when we're doing partial fraction decomposition. So go ahead and write this stuff down. This is pretty much the straightforward stuff you do. So here's your integral. And this is 1 less than this, so that's when you can do it. So first, you want to take that denominator and factor it. That's not an obvious one to do. You end up doing it, factoring each term at a time, or 2 terms at a time. It's by grouping, essentially. So you do this by grouping. You factor out x squared here, and then you factor out a 4. And you're left with 2x minus 1, 2x minus 1, which factors out, and you're left with this. So now one of the factors, 2x minus 1, is linear. So you do the same thing we did above. And then this is your irreducible quadratic over the reals. And so you need to do the, in this case, I wrote it as bx plus c. So this is where you would go next. So you write that integrand equals, or the rational expression equals a over the 2x. That's your linear case. It's done. That's it. If you had a power up here, that's when you do the 2x minus 1 to that power. Okay, so then, so now you have this irreducible quadratic. That's when you have to say bx plus c over that whole thing. Okay, and then the process is the same after that, but sometimes we're going to solve it and see how we can do that. Okay, so let's take a look. So multiply by the LCD, so we did that. Okay, so you get x squared minus x minus 21 equal to a times x squared plus 4, and then that cancels, and then plus bx plus c times your 2x minus 1. And then we need to solve that. Okay, so now this is when it gets a little more complicated. Like if you pick x to be, so you can't eliminate this whole term because you can't pick a value for x to zero this out. We may pick a value for x here to simplify it, right? Because you have 2x minus 1. If you pick x to be a half, then this will zero out. And you may solve for a. But given this form, this is when you pretty much want to expand it and equate coefficients. So let's do that. So this is equal to ax squared plus 4a, and then plus, this will be 2bx squared minus bx, and then plus 2cx minus c. Okay, let me double check that. I did not do this ahead of time. So ax for 2bx, here's your 2bx squared, and then distribute to here, negative bx, and then your 2cx, and then minus c. Okay, we're good there. Now we want to bring together our terms. So we want to look for the squared terms here, just the 2 of them. And then we'll look for the linear case, which is just these 2 right next to each other, and then your constants. So you want to collect. So it'll be a plus 2b, and then you factor out the x squared. And then plus, that'll be 2c minus b, and you factor out the x. Looks good. Okay, and then you get plus 4a minus c. And so then that's what we're going to set the a plus 2b equal to 1. And then we're going to set the 2c minus b equal to negative 1. And then we're going to set the 4a minus c equal to negative 21 and solve that system. Okay, so you have 1 equal to a plus 2b. We have negative 1 equal to 2c minus b. And we have negative 21 equal to 4a minus c. And so this is your system you're solving. And so you may want to write it like I would normally write a system of equations. A plus 2b, and then that's a plus 0c equal to 1. I'm going to put in placeholders just for fun. That's negative b plus 2c equal to negative 1. And then that's a positive 4a minus c. That would be a plus 0b equal to negative 21. So normally when I write the system, I want to have your a's lined up. I need to put the 0a in there. 0a, you don't need to do that part, but okay. So now you want to eliminate, however you want to solve it really.